Good day, students. You are welcome to math class. And in today's class, we shall be looking at the topic measure of central tendency, an aspect of statistics. And here are the learning objectives for today's class. At the end of the lesson, learners should be able to describe the term measure of central tendency, should be able to identify the three commonly used measures of central tendencies, calculate and interpret the mean of group and ungroup data by direct methods and assume mean method. So these are the learning objectives for today's class, and it is expected that at the end of this class all learners should be able to carry out the following tasks. And our Bible reference is taken from the book of Luke 14:28, which says, "For which of you, desiring to build a tower, does not first sit down and count the cost, whether he has enough to complete it?" I'll take it again. "For which of you, desiring to build a tower, does not first sit down and count the cost, whether he has enough to complete it?" It's taken from the book of Luke 14:28. Measure of central tendency. The word measure of central tendency is a statistical measure that identifies a single value as representative of an entire distribution. Yes, I want to believe that we are not new to statistics. Of course, we know that statistics has to do with collection of data, interpretation, analysis, and presentation of information. Of course, when we collect the data, there is need to process the data, there is need to analyze, there is need to interpret, and there is need for us to present such data. One of the tools that is used in processing data is the measure of central tendency. And I have said that it is a statistical measure that identifies a single value as representative of an entire distribution. The measure of central tendency aims to provide an accurate description of the entire data. It is the single value that is most typical or representative of the collected data. For instance, if you have different figures, say you have 4, 5, 7. Now, how can we get a single value that can give us a description of the entire value? So a means of getting a single figure that could be a representative of the entire data is central tendency. Now, there are several statistical measures of central tendency, and most times we call this central measure of central tendency averages. So we have different measures of central tendencies, And the three most commonly used are the mean, median, and mode. I repeat, mean, median, and mode are the most commonly used measure of central tendency. Now, in this class, we shall lay more emphasis on arithmetic mean. Our discussion today will be measured on arithmetic mean. Now, we need to talk about arithmetic mean. Now, there are different types of arithmetic mean, which in most cases we call mean. The word arithmetic there is just like an adjective to tell us the type of mean that we are talking about. Of course, there are different types of mean. We have the arithmetic mean, the weighted mean, the geometric mean, and the harmonic mean. So if mentioned without an adjective as mean, then it is generally referring to the arithmetic mean. So don't be confused when you hear mean and when you hear arithmetic mean. If you want to say the full name, it means you need to use the adjective arithmetic. So you can call it arithmetic mean, and if not using the adjective, then it could also be called the mean. Arithmetic mean. The calculation of arithmetic mean can be studied under two broad categories, and the first is arithmetic mean for ungrouped data. We also have arithmetic mean for grouped data. Briefly, what do you understand by ungrouped data? Ungrouped data are such data that are available without any classification. You've collected the data and no classification has been done as regard, let's have the first set of data to be in this class or in this category. So that is ungrouped data. And on the other hand, we have the group data. Group data are well classified. They've been assigned class based on their elements. So we are going to take our calculation on these two categories. We have the calculation of arithmetic mean for group data and the calculation of arithmetic mean for group data. Okay, so let's look at this arithmetic mean for series of ungrouped data. We have two methods, and the first method is the direct method. And using the direct method, arithmetic mean is the sum of all observations. The sum of all observations in a series divided by the total number of observations. I'll take it again. That the arithmetic mean by direct method is the sum of all observations in a series divided by the total number of observations. And it is usually denoted by X bar. As you can see, we have the X bar. So generally, if there are n observations such as x1, x2, x3, and so on to the last value, which is xn, then the arithmetic mean is given by the sum of all observations, which are x1 plus x2 plus x3 up to the last term, which is xn, then divided by the total number of observations, or you can say the number of elements, which is n, and that is the formula representative of the arithmetic mean of ungrouped data. Now, the arithmetic mean for series of ungrouped data can also be represented in a simpler form using the symbol summation. The symbol that looks like here means summation. So that is to say that summation of x, which implies the addition of all the observations. So it's a simpler way of representing the previous formula. So arithmetic mean represented as x bar is the same thing as summation of x all over n, where summation of x means sum of all observations and n is the total number of observations. Now this formula can only be used when handling small data. Of course, you could use it when handling large data, but the challenge is that the work looks more tedious. It is very, very stressful when you use this formula when you're handling large data. Okay, we're going to take example 1. Calculate the arithmetic mean from the data showing marks of students in a class in an economics test. And here are the observations. There are 40, 50 marks, 55 marks, 78 marks, and 58 marks. So, applying the formula summation of x, which means addition of all observation. So, by the time you had all the observation and you divide by number of observation, which is 5, we are going to come to this answer 56.2. So the average mark of students in the economics test is 56.2, which is the arithmetic mean. I want to believe that this is clear and simple enough. Okay, let's take another example. This is large data, and in the case of this large data, I think what we need to do is to tabulate the observations. We can make a table. We can use the tally system since we have reoccurrence of some observation, and that will help us a lot. That is, the use of tally and the frequency table will help us a lot. A police station kept record of the number of road traffic and accidents in their area each day for 100 days. The figures below give the number of accidents per day. We have to find the mean number of accidents per day. Find the mean number of accidents per day. And here is the solution. Now the first step is to draw out and complete a tally chart. Of course, we know how to complete a tally chart. Now if you look at the data given, 0 occurs thrice, and that 4 times, and that is why we have the tally stroke. You have 1, 2, 3, 4. So the frequency there is 4. 1 has a frequency of 10. So as we can see, we know how to represent the tally system. A pack represents 5. That's a complete pack. 1 stroke represents 1 observation. So we have it up to number 8. That's the last observation on this table. Now if you look at the frequency, for you to know that what you are doing is correct, you need to sum up all the frequencies, and it must give you the number of observation that is available. As you can see, we have n, which is the number of observation, to be 100. Now for you to get each observation, then it means you multiply by the frequency. you multiply by the frequency. Of course, 0 occurring 4 times multiplied by 4, that gives us 0. 1 multiplied by 10, as you can see. So we get the corresponding summation here. So at the end of it, you need to sum up your number of accidents multiplied by frequency, and that will give us a total of 323, which represents summation x. And at times it could be summation fx, summation fx, or summation x. So the mean number of accidents is given as summation fx or x divided by n, which is the number of observation, and that gives us 323 divided by 100, which gives us 3.23, and that is the mean for this solution. Okay, we can also calculate the arithmetic mean for series of ungrouped data using the assume mean method. Remember, the first method used is the direct method. Don't forget, we are looking at ungrouped data. Now, here are the steps involved if you are to use the assume mean method. Now, why do we have to use the assume mean method? If the number of observations in the data is more, it is very difficult to compute arithmetic mean by direct method. If you have large observations, so it's very difficult to use the arithmetic mean method, especially when the observations are not reoccurring. So it is very important that we learn how to use the assume mean method. And using this assume mean method, the computation can be made easier by using assume mean method. Here you assume a particular figure in the data as the arithmetic mean on the basis of logic or your own experience. Just choose one out of the observation or data that is available based on logic or your own experience. As we go on, I'm going to tell you the tactics of choosing the mean, the assumed mean. Then you may take deviations of the said assumed mean from each of the observation. Whatever value you choose it to be the assumed mean, then you can take the deviation. Of course, the deviation will be the difference between the assumed mean and each observation. You can then take the summation of these deviations and divide it by the number of observations. After you've gotten the deviation for each data, then you can take the summation and you divide the summation by the number of observations in the data. Then the actual arithmetic mean is now estimated by taking the sum of the assumed mean. The assumed mean is usually represented by capital letter A. Take the sum of the assumed mean and the ratio of the sum of deviation to number of observation, and this can be represented symbolically as thus. If A is the assumed mean, like I said, X represents the individual observations, N is the number of observations, while D is the deviation of assumed mean from the individual observations. Of course, my assumed mean is A, so the deviation will now be take the individual observation, subtract the assumed mean from the individual observation, and that gives you the deviation. The sum of all deviation is then taken, which is summation x minus A, or sometimes summation D. So then when you get this ratio of the sum of the deviation and the number of observation, then you add it together with the assumed mean, and that gives us the arithmetic mean. I want to believe this is clear enough. If not, you can always go back to this slide and get detailed explanation. So, using the assumed mean method, the arithmetic mean is given as the assumed mean chosen by logic or your own experience plus the deviation from the assumed mean and the individual observation. So don't forget, you are looking for the ratio of this deviation and the number of observation. Now, I want you to take note of this. You should remember that any value, whether existing in the data or not, can be taken as assumed mean. So this will not affect your final results. You can use any value, whether existing in the data or not. You can take it as your assumed mean. And however, in order to simplify the calculation, it is advisable to choose a centrally located value in the data as the assumed mean. Oh, for instance, if you have 2, 3, 4 as the observations, then I will advise you pick the centrally located value. Here the centrally located value is 3. Instead of picking 4 or 1, it is advisable you pick 3 because 3 is centrally located. So don't forget, I also said it, that any value, whether existing in the data or not, can be taken as assumed mean. We are going to see that in an example here. Now, looking at this example 3 now, the following data shows the weekly income of 10 families. As we can see, family A to J. We have the family, we have the weekly income in RS. Now we have to compute the family, we have to compute the mean family income. Now you need to make a table. Now if you look at this table, very well, you can see we have the families, then we also have the income, as you have seen, which is X. Now, the first thing we need to do is to choose the assumed mean. Now, if you look at it, I said any value can be chosen as the assumed mean. Now, here I have chosen the first observation, which is 850 for family A as my assumed mean. So if my assumed mean is 850, then my deviation will now be for family A. Now don't forget, your deviation is the observation minus the assumed mean. So if I take X minus A, and that will give me 850 minus 850, which is what? 0. If I take it for the second observation, it means I'm going to get 700 minus 850. That gives me minus 150. If I take observation C, I'm going to get 100 minus 850, which gives me minus 750. Okay? And we continue like that. And at the end of it, we get all the deviation for all observations. Then we can now sum up all the deviation for all observation. Okay, so we could see that the summation of all the deviation is now giving us 2,660. That is the summation of all the deviation. Now, to calculate the assumed mean, let's take the assumed mean plus the summation of the deviation all over the number of observation. So here we have 850 plus 2660 divided by 10. And if we do that correctly, we are going to get our mean to be 1/116, which is the assumed mean. Example 4. If you follow the same steps, this is what we get. Look at the data given clearly. So the first thing we need to do is to choose the assumed mean. Here we have chosen 16 as the assumed mean. Don't forget, you could choose any of the value, though it is advisable to choose a centrally located data. Here, if our assumed mean has been chosen to be 16, then the next thing is to find the deviations. So when we get the deviation, we have the following figure. We have since the assumed mean is 16, so x minus a, that is 3 minus 16. 3 minus 16 we give minus 3, and so for all the observations. So we could get our deviation. Okay, now we can get our summation of the deviation multiply summation of the frequency and the deviation, of course. So when we do that, we get minus 22. Then we divide by the number of observation, which is 40. Then we add the assumed mean, and that gives us 16 minus 0.55. Here the mean is 15.45. Of course, you can always use the direct method for this and you will still get the same answer. You can always try this. Okay, we are also looking at the calculation of arithmetic mean for group data. We've talked about ungroup data, and as I have said, group data have their observation classified already. They've been assigned class. Okay, and when we are looking at this, we are going to look at discrete series. Discrete series in such a way that we know the number of terms. Okay, the frequency against each observation is multiplied by the value of the observation. The values we obtain are summed up and divided by the total number of frequencies. So this is just easy and direct. Okay, and we have the formula here, which is summation fx all over summation of all the frequency. And this is an example, and this is a direct. Here we have the frequency, so we multiply each observation by the frequency, and when we do that, we get fx. Then we can now sum up the fx, which is summation of the frequency and the observation, and that gives us 33,000 divided by 260, and that gives us the mean as 126.92 square meter. And I want to believe that is simple enough. You can go over the slides again for detailed explanation. Okay, using the assumed mean method. Now, if we are to use the assumed mean method, since frequency of each item is given here, we multiply each deviation by the frequency to get the FD. Then we get what we are supposed to get. So we are going to get our EFD, which is the summation of the frequency and the deviation. Then the next step is to get the total of all frequency, which is summation F, then find out this ratio. Then we add it together with the assumed mean. And we're going to take this example. So as we can see, this is grouped data. You can see this is group data. Find the mean mark of students using the assume mean method. You can see the class. We have from 0 to 10, 10 to 20, and up to 40 to 50. And here is the solution. The first thing to do is to get the deviation. And here we have what we call class mid value. Since we have a class, so you could just take the mid value of each class. For example, for the first class, the mid value is 5, and the mid value can be obtained by adding the upper class boundary and the lower class boundary. So for the second group now, you have 10 plus 20 divided by 2, and that gives us 30 over 2, which is 15. So that is the class mid value. For the other one, you have 20 plus 30 divided by 2, that gives you 25, which is the mid value. Okay, and that will be taken as a representative for each class. Now the deviation is obtained by removing or by subtracting the assumed mean from each class mid value. So for the first one, I can subtract 5 from the assumed mean. Here my assumed mean is 25, so I can say 5 minus 25, and I will get minus 20, and so on for the other group or for the other class. So at the end of it, you need to multiply the deviation with the frequency. Multiplying 12 by 20 gives minus 240. 28 multiplied by minus 10 gives minus 280, and so on, like that, up to the last class. Then you can find the summation of the frequency and the deviation. And once you've obtained that, then we can divide the summation of the frequency and deviation by the summation of the frequency, which is 100. The summation of the frequency here is 100, and we can add the assumed mean, which is 25, and we get the mean mark of the students to be 24.9, and that is the mean mark. And that is the mean marks. Don't forget, the difference here is that the class mid value is used as a representative for each class, and the class mid value can be computed by adding the upper class boundary and the lower class boundary. Then you divide by 2. For the first class, we have 0 plus 10 divided by 2, which gives 5. For the second class, 10 plus 20 divided by 2, which gives 15. And that's the difference. And that brings us to the end of this class. Any question? Okay. It is very important you go over the portal, check the class notes, and on the portal you get numerous exercises that you need to submit. You also need to practice this, and that will give you a better understanding of the topic. And don't forget, at the beginning of this class I said that as a learner in this class, you should be able to describe the time measure of central tendency and identify the 3 commonly used measures of central tendency, then calculate and interpret the mean of group and ungroup data by direct method and assume mean method. I want to believe that these objectives has been achieved? These are the questions you need to ask yourself. If not clear, then you need to go over the video over and over. Thank you for listening. Have a good day.